Hello, folks. Welcome back to the Practical Microservices stream. Got the meetup in 2 days. I need to put up the event for it. I think what we're going to do for it is to take the what am I trying to find? The telemetry library. So if we go to and search for event tied telemetry, not necessarily a super deep dive into telemetry. I think someone else may give a more general presentation on that at some point. How can general mean deep dive? I mean, the point of this one isn't specifically to cover everything to do with the telemetry library, but what I'd like to do is give basically the high level overview of what it is, but then look at it specifically in relation to the portions of event tied that make the write substitute work. So when we go to messaging lib messaging write, there is also this write substitute class here, and messaging write has this message writer dependency. I think. Why won't you? Oh, because, right, it's already as tall as it can get. Oh, and right, I don't have this bottom part visible. Let me fix that. There we go. All right, so let's see here. And then the other place I want to look at is in, I believe, consumer Postgres. That is right here. Yes, I meant to vertically split that though. So within the consumer Postgres gem and lib consumer Postgres, there's a configure method, and in here it sets up a few different things. I may be thinking of the wrong thing here. Message store Postgres session configure. It's how the consumer gets its session. Message store Postgres. This has nothing to do with what I'm thinking of, I don't think. I think I want messaging Postgres real quick. Messaging Postgres lib Postgres write. Okay, right. So from our handlers, a handler typically has a configure method on it. I've lost sight of the chat now. Here we go. I can show an example of that. So let's see here. Account component lib, account component handlers, commands RB. Why not? Messaging Postgres write configure, which is right here. And you can pass it a session. You can receive the same session that your consumer has right there, and then pass it along there like so. I'm going to undo those changes real quick. But anyway, so that's the messaging Postgres write then is the actual writer. That's this message writer dependency right here. So that is a dependency on a lower level writer that deals in message data. Whereas when we call messaging write, we're dealing with message class instances, which incidentally was the topic of today's email. Let me pull that up real quick. So if you were to subscribe to the list, you would get this delivered straight to your inbox. But we're basically doing the TDD flow that we've done on the stream a lot, but doing it in the email because different people subscribe to the list, then watch the stream. Unless you subscribe today, then you help make those two sets identical, and that's just a win for everybody. Anyway, we went through how you turn a plain old Ruby object into a message class. And let's see, where did we actually do that? That's the handler. There we go, module commands. I left out some of the namespacing because in an email, I don't want to take up all of the space with just duplicated text, but including messaging message turns a Ruby class into, well, anything you include it onto into a message. And so that's what write is using, or messaging write is dealing with those. And in messaging write, this is a module that is then included into the Postgres variant. So if you had some other message store and there are some in disrepair implementations to do this for Event Store DB. But if you were going to use a different message store technology, then you would need to write your own variant. So messaging whatever store you're using with a class write. You can call it whatever you want, but you might as well have it have the same name so that it's easier to keep track of. But and then you would include messaging write so you can get the stuff that's common to writing no matter what the store is. And in fact, this is something I want to do once we finish the port of video tutorials to Eventide. I want to try to make Eventide work with other storage mechanisms. Like there is the popular and incorrect conception that Kafka is good for event sourcing. It isn't at all good for event sourcing because it's not a message store. It's a message transport and it's good at what it does. It can be difficult to operate, so only operate it if you need that kind of scale, but it's not a message store. It doesn't have the critical features that a message store needs. That's fine. It's not a knock against Kafka. It's just not what it's built for. But I want to do my part in dispelling that myth by trying to build Eventide gems that would work with Kafka, and then we'll see where it fails as a message store. Anyway, it might be fun to do that too with just writing to a plain old text file and seeing how that turns out. Probably not brilliant, but it'd be a fun experiment, and that's the kind of thing you get to do on a stream. Anyway, the point is I'm trying to make is if you look in messaging write, you can see it's using somewhere in here telemetry. You can see it right there. So it has a dependency on telemetry right there. And then if you go, I'm going to go ahead and close the messaging Postgres write instance over or file over there. And so when you get to the actual calling of write, so if you remember from the file I just closed, that all the Postgres variant is doing for the write class is to have a configure method so that we configure an instance of message store Postgres write. The calling then is independent of the particular storage medium. And so this is the message call. This is the method that gets called when we call write, even on the Postgres variant. Within here, though, what you'll see is somewhere in here, we use that telemetry dependency. I'm hitting the wrong button, trying to highlight this line. We use that dependency to make a record that, hey, we wrote this message. And it is that telemetry that powers the write substitute that we use in our tests. And so here you can see the way that, let me mark that and come back up here real quick. We have a dependency on a message writer. Right, looking in the wrong place. So let me open up a handler class again real quick. So if we go account component, lib account component handlers commands.rb, we have a dependency on write, which is this class over here. But the way that dependency works, of course, is if you haven't, when you just instantiate an instance of a class with a dependency and you pass it the thing that it's supposed to mimic, it will check within the namespace of that thing if there is a substitute module in there or a substitute constant. I think I messed something up in this file. There we go. That should fix it. This substitute module does get included into the Postgres variant, which you can see in when we include this onto a class. It then goes into the context of the class and adds the substitute in there. If it finds that, it will look for a build method, and then whatever that build method returns is what will be used for the value of that dependency. So the what am I trying to say? So the write here, as it's writing, it's recording telemetry. Here is the substitute. What does its build do? Well, under substitute write, substitute write is a class here that also includes messaging write. So when you call on it, it's going to do what it needs to do there. Interesting how super works here. Maybe I always thought super was related to inheritance, but this is overriding the call method here. But passing all the stuff along, that gives us a way to, like with the right substitute, you can be like, hey, I want you to give me an expected version error the next time I call you. And so that's what this line is doing here. But otherwise, it just passes right on through to the call method defined in messaging right, which means that telemetry is kicking in even for the substitute instance. And then when you look through at all of the methods, like quite frequently in our tests, let's open just an example here again from the account component, because everything comes back to the account component. Test automated handle commands. Let's go with open and opened. We grab the writer. So that writer is an instance of this substitute. And then we call things like one message on it. Well, that is just a method somewhere in here that might have come from, oh, right. Sorry. It's aliased. Right. There we go. So it's this one message right that we're calling here. So when we look at the test and we say one message, we pass it a block with an event. Okay, well, here's that block that we got. So we're going to call message writes, passing it that block, which is this method right here, is the block nil, and so on and so forth. So I think it would be really interesting to dive into the right substitute and show how that leverages the telemetry library to enable that kind of inspection. We haven't done that with the substitutes we've made in the port thus far. What we've needed has been a lot simpler. We haven't been looking for a variety of different things that can be written, but I think that would make for an interesting meetup session. So this is supposed to be a day where we're continuing on with the event tied stuff, which means that I did the title wrong on the stream. Today's a Tuesday. You know what? Forget it. I'm not going to change it again. We're just going to go ahead and continue on with the send email client. Yeah. All right. Changing schedule. That's kind of been par for the course on the stream lately. But anyway, that's what I'm thinking we'll do Thursday night. And so I just need to type up a description about that and put it up on the interwebs. LiveView Technologies will be hosting us again. As always, we're ever grateful for that. If you know someone who needs to secure something, go check out lvt.co. And with that, let's actually get into what we're working on, which is continuing with making our client here. And so we got as far as not failing anymore. So we have the instance of our command that we want to write. And so, no, I'm sorry. It's not the command we want to write. This is our client class, which you can see right over here. And so, I don't think we'll end up using that. We need to actuate it. And we don't need to worry about what to pass it right now. It won't be any of those in any case. Now our test will fail because we don't have a method call on there. Oh, and because it isn't called deposit. Undefined method. Exactly. So we want to come down here and give it a call method. Test passes again. So now we need to start inspecting the message that it would write. So we can say write equals send.write. And you know what? Of course, we don't have that dependency declared. So it should be another no method error. It is. So then we would come in here, and I believe we need to include dependency. And then we would do a dependency on something called write. We don't have to call it write. I'm following the convention there, but its job is to write a message, the same as it is in a handler. So we're going to leave that name. Cool, we're passing. That's what I expected. So now we need to see, did we get this message back? So it wouldn't be a deposit message. It would be a send message. And typically, like if we were to go to the identity component right here and to our test that we have, excuse me, where we handle our registered event, Notice that we call the message just send. Well, we have a name collision if we try to do that. Send is the command class, not the command message class, but the class that's going to write the command for us. And so then we say send message here, which is also fun because it's not the act of sending a message. Message is a modifier for the word send. This also tripped me up. Let's go back to the event-tide code real quick. The first time that I really started diving into event-tide, we were trying to basically, we wanted to get data out of Salesforce, which, right, let's just accept that use of Salesforce was a good thing for the sake of argument. Anyway, that led us into the transactional outbox pattern, which is a topic of another discussion. But basically what it is you have some system that is not messaging aware, and you want to record changes that happen in that system. It's probably not designed with good like domain names for the changes. And so you're going to be dealing with CRUD operations, which is unfortunate. But Salesforce is such a system. Pardon me. Yawn. That's fun to do on stream. Anyway, what was I saying? Right. So what you don't want to do is say write some change in Salesforce and then try to write something to MessageDB, because you could pipe in credentials to a Postgres database into MessageDB. I'm sorry, into Salesforce. Probably. I'm guessing there's a Postgres connector inside of there that you can put in your Apex scripts, whatever the case may be. Because suppose you got all that piping working, you would write something to Salesforce, commit a transaction if you had one open, and then separately write to MessageDB. Well, that's not atomic. What if something goes wrong in between there? Now your Salesforce and MessageDB are out of sync with one another. And this is what the transactional outbox pattern can solve. I think of it as a transitionary kind of a thing. Transitionary, I don't think that's a word. The transitional approach, but what you can do is then within Salesforce they're called objects, not tables, I believe. I have a very fleeting understanding of how to customize Salesforce, but you have an object that is structured kind of like the messages table in MessageDB. And so when you make your change to your Salesforce object that you already were making a change to, there's a way to do that inside of a transaction. So you can write some event-like representation of the change. If you've got dedicated Salesforce developers, you could probably have that be a much better business type event than just a raw this object changed. Because if you have that where you have all the context of what actually occurred, that makes the later integration a lot easier than trying to infer later from a CRUD operation what actually happened. Anyway, so now you're writing this message-like record with transactional consistency with the original change. So either they both succeed or they both fail, which is just what transactional consistency means. It's probably a good thing that I spent all the time to really get into what the difference is there. Anyway, so now you've got a table that's structured kind of like the messages table in MessageDB. Well, I mean, event-tide already basically knows how to consume from a table structured like that. And so what we were doing was modifying the consumer, everything about it that was necessary to modify to get it to work against Salesforce. We were successful in that, by the way. So it can be done. And it was a real, to me, testament to how exceptionally well put together event-tide is. Like, I do not believe it was designed at all with the intention to support reading from Salesforce as if it were a messages table. But we were able to do it by just getting, like I was saying earlier, our different variants of the various pieces of the framework. So in the consumer config there in the Postgres one, we were patterning it off of this bit. This whole discussion got started because we have a variable named send message. And I was trying to say it's not the verb send a message. It's message modifying the word send. Anyway, in this setup, there's this get session variable. And I thought it was something like go get the session. But no, it's the session for getting. that was a rabbit hole. Let's get back to what we're doing. So, excuse me, that's the name of it there. So we're calling that write one message method that we just saw on the messaging write substitute class. And we want to make sure that an instance of our send command was written. Now, if we run it here, the test is going to pass because this block doesn't get executed because we haven't actually written anything. So we just want to make sure we didn't break the test. Which honestly, if we had left this as deposit, it still would have run to all green because we're not running the block. However, I know that's not what we want, so I'm going to put that there. Is that writing more code than we need to get it to pass? Maybe. Maybe we're doing this completely in the wrong order. Completely is a little strong there. We're doing this in the wrong order. Let's correct the method here. So the first thing we would need to do is we want a test to say that our send command is written. And to do that, we would need to make sure that send message is not nil, but send message isn't defined. So we're going to get, I forget the name, the specific name of the error. It's not no method error, name error. Yeah, it's a name error. Okay. You can see it right there. Name error. Neat. Okay. So, all right. Then we need something called send message. So we write that code and now we're going to get an assertion failure. Let's suppose that we could have gotten away with writing. Boy, I really want it. Like, what is the minimum amount of code to get it to pass after adding that assertion? So let's remove that real quick. Assertion fails. Okay, so then we would need a... Sorry, this wouldn't be the very next step. I'm going to put this code back in here though. So I don't want to retype it. But if I retyped it, that would help me learn how to type it better. Okay, so the assertion is failing. That's because we're not actually writing anything. So we could be like, write something. Now that dependency write at present is a mimic object, which is event-tied's implementation of the null object pattern. That pulled up Magic the Gathering. That's surprising to me because event-tied is one of the words here. Does this pay? Oh. That's so funny. Kind of want to save that real quick. Event-tied project mimic. So if you're searching for event-tied stuff, you pretty much always have to put the word project in there because the word event-tied is used in a lot of different contexts. That's okay. Anyway, mimic. Null object pattern, basically. So this call won't fail, just won't do anything. So our assertion will still be failing. Yep. So we need to write something. But even if we write something, it won't matter. We need this to actually be something. So it would be a messaging Postgres write instance. Now we should get an error because we're trying to write with the wrong number of arguments. Yeah. Given 0, expected 2. When you write a message to a stream. So we'll need a message to write. We could write anything there. And at this point, let's do that. Although it does need to actually be a message because write won't work with something that isn't a message. So we might as well get send equals messages commands send.new, let's say. And then we will write that to some stream, which is the fill-in that I always use when we're at this point of the development flow. Test is passing. Neat. So we wrote something. But what's interesting to me here is we would also like to validate that it was the correct type of message that was written, because what other messages do we have in here? I think we have the sent event, right? We could be like, we could just type that in and this test will still pass. That's not right. So we want to further refine what it is we're saying was written. We really want to make sure that it was an instance of messages, commands, send. Because if it's not one of those, we most likely wrote the wrong thing. So now if we run the test, the assertion will fail again because what passing the block does, if you don't have the block, it's just like, was one message written? Sure. Okay, cool. The block is going to filter it and it's only going to say, yes, a message was written if this block returns true. So we're just putting in the block, hey, event, are you an instance of messages command send? So if we run that, now it wasn't. So this comes back as nil and we're refuting that the send message variable is nil. So we should get an assertion failure again. That's what we got. Awesome. So we can just come back here and put it back the way that we had it. And now everything should pass again. Neat. So we're writing a message and it's of the correct type. Good stuff. So now what we need to do is make sure we wrote it to the correct stream, because if we're trying to use this class for other clients to write us send commands, well, then they better well be putting them in the stream that we're looking at to find those. Otherwise we won't find it. We won't do anything with it. So we can uncomment this bit of the test that we ripped off / were inspired by from the account component. And we would want this to go to the send email command stream. And the way that we would do that is make an assertion that it was written to the stream. But of course, written to stream doesn't exist. So we get a name error on that. Well, let's make it exist. And to do that, we want to say, hey, send message. Helps if we type it correctly. Well, we're asking the right substitute again. The same thing that we asked this one message thing of. We're calling its written method. I love that about Ruby, that method names can have question marks at the end of them or exclamation points. And so you would just find that somewhere. There's a def written message somewhere. The convention with that is if it has a question mark, it returns true or false. And we pass it that message that we know has been written. And we pass it a block that, again, we want this thing to evaluate to true. Or rather, written to stream will get populated with a message for which this evaluates to true. So we want the stream name to be send email :command, and then we would need an identifier for this, which would be an email ID, or rather, I think we've been calling it transmission ID. Now, transmission ID, does that exist in this file? Not yet. So if we run it, we're going to get a name error on transmission ID. Just what we expected. So that's good. So we need to put that in there. Where would we get it from, though? And I guess I called it email ID up here, but I'm going to stop calling it that. I'm going to call it transmission ID. And this control, the controls, of course, are ways that we get example data of the thing that we're operating on. Let me open that. We have this ID control here. We're saying that there are transmission IDs in this part of the system. Well, how do I get an example of that? That's what the controls job is. For any construct, really, that we have within our system, as a developer, we want to write examples of those. Why? Well, it comes down to things that change together should stay together. You don't want to have to make changes across boundaries if you don't have to. That may happen sometimes, but ideally, if two things always change together, they belong in the same place. And so what we're saying is examples of our data constructs are dictated by the code that owns them. It's not dictated by the test. So what would cause us to need to change our data examples? It would be the actual code that uses them or that owns them. And so that is why we provide these controls. As developers, we provide these controls, not as testers, not as users of our library. We don't want them to have to come up with fake data in their library. That's silly. It's our responsibility as a developer or something to provide examples of the things that we're developing. So anyway, that's what this controls bit is about. The first time I came across this, I thought it meant UI controls and I didn't understand it. But no, it's controls in like the scientific method sense of the word controls. This is a controlled example of the data. So you want to know what transmission IDs look like in the system? Neat. This thing will tell you. So we have that in place. So now we have a value for transmission ID. So we won't get that error anymore, but we're still writing it to some stream. So we expect this assertion to fail on line 29. Oh, I did something wrong. Oh, I didn't save the file. That would be it. You have to save files for changes to take effect. And sure enough, assertion failure. So we need to write to the correct stream here now. And what should that stream look like? Well, we wrote it right there. That's what it should look like. So we need to somehow get stream name to equal that value. So for that to work, we would need to, this method, I'm going to go ahead and close that control up there. This method would need to have access to that transmission ID. And we will just start out by saying you have to provide it that, and probably going to leave it that way. In the account component example, that's optional. If you don't supply one, it will generate one, but we're going to say it's required for our purposes because we'll already have that value in our client. We know that. And until we have a reason to make that optional, let's not have it be optional. So then we would need to pass that transmission ID. Okay, let's make sure we still have the assertion failure and that we didn't make an error in connecting the call definition to where we call it. We got wrong number of arguments because I didn't save the file again. Okay, so we still have the assertion failure. Neat. Okay, neat. So now that we have the transmission ID, we could just straight up do send email command and drop that in there. And now the test should pass. It didn't. Okay, why did that not pass? Because I spelled command wrong. There's that. Now it passes. Awesome. Good first step. Now that we have green, we can refactor a bit. This works well enough, but we can do something else. There is a line that appears in a lot of our handlers. Let's go look at it real quick. We pull in messaging stream name. What that does is it gives us access to a number of methods that are helpful for constructing stream names. Send email, like we will need to supply those characters somewhere, but I don't like having to do the command bit here. That's what's called a type modifier on a category. If you want to learn more about that, if you go to docs.eventtideproject.org, user guide, stream names, let's see, category types. This gets into what the colon represents and what the words after the colon mean. But command is a type modifier of the stream category. So going back to the code real quick, this is a category about sending emails. We are modifying that category to say it is a stream containing the commands related to sending emails and then the email of this particular transmission ID. Maybe I should say transmissions instead of emails. So rather than hard coding the command like that, what we can do is also include this messaging stream name here on our command class. That gives us access to two things. One is this category macro that we put in the class definition. So we can just write down here, say category is send email. I believe it does the casing conversion. So I just wrote that as snake cased. So spaces are underscores and Everything's lowercase. But typically when we write things to the message store, we use camel casing. I think we can write it either way and then it works. Well, clearly we can because we did it before. So, but then the other thing that it gives us is a method called command stream name. Because we've already set the category, we don't have to supply that anymore. And command stream name is going to take whatever our category is and add to it the category type modifier of command. So that the only thing we actually need to pass in there is the identifier that we're after. Like so. So that should all still pass. Which is great. So, which is better? Let me copy that real quick and we can go back to what we had before. This bit here, we still have to effectively hard code right up there. And not duplicating that. If we were to add other instances of having to construct one of these stream names in here, not repeating that, of course, makes it less likely that we would make an error. We could have also achieved that by being like category equals send email. And then down here, we could have replaced this with category. But it's still like, I don't know, the more you're hand constructing strings like this, it feels kind of, pay attention to that, and manually managing type modifiers and stuff. It's just, you can do it. My JavaScript code did that all over the place. All the stream names were hand constructed strings. There is less opportunity for me to make an error by just leveraging the methods that the framework puts at my disposal. So that's why I'm going to stick with that one. And just to make sure I didn't mess anything up as we were exploring there we are. We're back to green. Great. Okay. So we've got a message of the right type written to the correct stream. That is a start. However, that won't be enough to actually send the email. So now we want to get into testing the attributes. And you might say this feels a lot like a handler test. Well, I mean, it is a lot. What does a handler do? You give it a message and you check to see what messages it produces. Usually one, but it could be more than one. If the handler also produces some other side effect, you'd have, I mean, we did that in the send email component because we send an email and then we record the message, and we talked through all of that. Hey, Alvi, yes, this is Ruby code here, not Python, although the languages don't look all that different at first glance. But yeah, we're doing Ruby code using something called the event-tied project. What is practical microservices? I'm glad you asked. 1 second. It's a book I wrote. That was totally dorky, but yeah, I wrote a book called Practical Microservices that talks about an architectural pattern called microservices. I wouldn't say I'm famous, not at all. I wouldn't say it's a super widely read book, but yeah, I wrote it. And it builds a system using an architectural pattern called microservices. And the code in it was done like back-end stuff, website server, close-ish. A website server, I wouldn't call back-end stuff, but how to think about it. What would be an example? So an example we did for a meetup was, suppose that in your system, you wanted to send an email, for example. You could write a real self-contained chunk of code that focuses only on sending emails, that doesn't have to reach out to other things to get the data that it needs. You can just send it a command and be like, do this, and then it will do it or not do it. That kind of self-contained thing, we'd call that a microservice. That's a very rough description of what it is. Hey, SB Ditto. And why would you do that? So like, if you have a whole bunch of these, it could be painful getting them all deployed, keeping track of all of them and whatnot. But the benefit of it is if it's really self-contained like that, if it doesn't need to reach out to other things, then you can work on it independently. So like if you and I were at the same company, working on what you were working on, whatever you're working on, and I'm doing what I'm working on, we don't end up clobbering one another, or I don't push some code that messes you up and breaks you. And so we're able to move independently and safely. That's the advantage of microservices in a nutshell. Makes it so that your code doesn't keep you from having teams working safely together, basically. So like what I'm doing on the stream here is the code in the book was in JavaScript, which is used a lot in web stuff, obviously, because it's what runs in browsers. I'm porting it to Ruby, breaking app into small teams. Yeah, basically. You would still get benefit from microservices even if it was one team, I think, because it just gives you things that can be worked on independently and safely, and that is powerful. Like, I don't know, are you a developer yourself by chance, Alvi? Okay. Yeah, so if you've worked on a large one, you've probably heard the term monolith. We don't need to get into like precisely what that means, but you work on these gigantic applications and you go to make a change in this part over here and you're like, oh cool, I can just make a change here, but then you find out these 7 other places that are affected by that. And that kind of interconnection of all of the code makes it so difficult to work as separate teams. And I'm not big on like separating things just for the sake of doing it. Like, it's nice when, like, especially within a team, everybody knows what's going on within the team. But if we are growing, like suppose you have 50 developers, like that's way too big for one team anymore. And ideally you would have them working on different things. Like you'd split up into, I don't know, if you had 50 people, probably don't want more than like 10 would be a rather large team, but let's just go with 10. You have 5 separate teams. It would be nice if they could work on separate work without having to coordinate with one another. Because as soon as they have to start coordinating with one another, everything grinds to a halt and it slows down. Because I can't make a change without verifying with 4 other teams that change isn't going to break them. Well, that's where you're like, this project was supposed to take 6 weeks and now it took 1.5 years starts happening. Just all of the delays that get introduced there. So that's exactly what microservices is about, is making it so that you have portions that can be worked on independently so that your work can keep flowing and advancing. That's the real benefit of it all. And so let me just pull up real quick the specific library that we're working with. Sorry, that's the docs page. I just want eventtideproject.org. This is a Ruby-based toolkit, framework, whatever you want to call it, that gives you the tools to build things that way. It's still difficult. Well, it's not difficult, isn't right. It's a different way of designing things. Like most web apps, I don't know if you've done MVC things like Rails or Django, they're always like, oh, start with your users table. And then every single attribute that could even possibly relate to a user goes in there. Designing apps in that way will feel very painful if you're using Eventide or any other microservices based thing, because it's that way of designing that leads to what a monolith is. But anyway, yeah, I talk about that a lot in the book. So if you're interested in that, I don't know, if you have a Safari online subscription, I think it's there. But anyway, yeah, that's what we're doing. We're taking the book code and moving it over to the Ruby-based Eventide. In terms of performance and scaling, how is Ruby for large web apps? I'll start answering that question by saying that there are incredibly large sites that use Ruby and they're doing just fine. So GitHub, the main app that you interact with there, I believe is still a Ruby on Rails project. So ultimately it's running in Ruby. And Shopify, same thing. So they're a household name, let's say, both of those organizations. They both use Rails. Ruby is often like pegged as not the fastest language out there. And I think that's accurate. But it does just fine. If GitHub and Shopify can run with it, then I don't know. I haven't yet worked at a place that was as large a scale as those. And so I think Ruby sufficiently has covered anything that I've worked on yet. Where you might not want to use it is like ultra high performance things like real-time stock trading, or like building a video game where like every little CPU cycle matters. For most web apps, that's not the case. So I think it's typically like similar to Python in terms of performance and scaling, but I don't know. A lot of people poo on Ruby these days, and I don't get it. There's always the hype cycles, like some new technology comes out. This is the next great thing. Everything should be built on this, and we should rewrite everything that isn't. And Ruby was that language at some point, and now other things are coming along, and people have trouble with their apps, and they're like, oh, well, it's Ruby's fault that I have trouble with my app. And I just don't think that follows, but I think it's a fine choice. I like Node as well. Node's great. I'm unfamiliar with Python, but lots of great websites were written with Python. Up until recently, Khan Academy was a Python website. I think they recently changed over to Go. Don't know why they chose Go, but they did. It worked for them, and that's fine. So, oh, neat. So you're about to learn Ruby yourself. That's fantastic. Yeah, I think it's a great language. There's work to be found with it still. So good luck with that, and always feel free to drop by if you have questions. Hey, Lord Crispy Chicken, welcome back. Good to see you again. Yeah, cool. So we've got about 4 minutes left, and we're making progress on these tests. So the kind of general way that the technology that we're building this with, Eventide, operates is like, you're probably used to the model where someone has a browser, and then you hit a URL and it fetches something from the browser. And then, oh, you're not going to be doing coding anymore. No way. That's sad. It is tricky to get started. But I'm sorry to hear that you've made that determination. I'm not going to tell you what you should or should not do. But I'll just say this, and I'll leave it at that. I work in this professionally now, and I think I'm decent at it. My first attempts at learning to program, let's just say it took me many tries before I felt like I could do basic things. It was hard for me to do the learning on my own when I was a lot younger. I can do that just fine now, but when I was younger, I would buy like Teach Yourself C++ in 21 Days. There was a book called that. And every time I worked through it and got stuck, I was like, I don't know what to do. There's no one I can ask a question of. But anyway, I don't know. Make your decision. Just know that I think for those of us who have been doing this for a while, in the early days, we might have felt how you're feeling now. Alvi, though, to your question, how many total backend technologies do I know? I did do computer science in university. I double majored in computer science and French, because why not? But how many do I know? I have worked professionally with Ruby and Node and PHP. I wouldn't say I know PHP very well, but if you gave me a project, I could probably figure it out. I think I have messed around with Django just a little bit. I think at one job I did have to make a change to a Django project, which is the flagship Python web framework as I understand it. So too well, I would say. And then I've dabbled in a couple others. Professional means jobs, yes, where someone paid me money to do it versus just experimenting with it on my own. These days, I mostly use Ruby, but it's just basically what part of my career you find me in. I did almost all Ruby. No, it was exclusively Ruby from, say, 2007 to 2013. Then I did Node almost exclusively for, I don't know, 7 years after that. And now I find myself doing a lot more Ruby. So to land a job, did I have to make big projects, or how did I get my first job? So my first job out of school was actually not web development at all. I did device driver development for a company called National Instruments. Very different world than web development. And while I was there, there was a friend at my church who was just like, hey, we're having trouble finding people who know Ruby, so we're branching out to programmers in general. Do you want to interview at my company? And so I did, and I did well on the interview, I guess. They were cool. They didn't quiz me on a lot of Ruby specifics, but just general programming knowledge. And that's how I got it back in the day. I had never worked with the friend, so I don't know that he necessarily put in a good word for me per se, but yeah. They didn't give me hard leak code problems at all. There were some challenging ones that talked about general programming patterns, things like the visitor pattern, which may not mean a lot to you, but I'd encourage you to Google visitor pattern. But just like general stuff that I have a basic, it was a junior position for sure, but a basic understanding of how to do database operations and whatnot. Is functional programming important? Oh, that's a can of worms to open up. I am very sympathetic to functional programming methods. SB Ditto, from what I've seen of your responses on the stream, you are too. So usually when I would advocate for functional programming, it was in contrast to object-oriented programming, and I really liked functional programming compared to what I understood of what object-oriented programming was. And the trouble with OOP is it's taught poorly, in my opinion. You get, like, the classic line is when you're designing an OOP program, nouns are objects and methods are verbs. And that leads you into terrible designs. This is something I'm really grateful to, again, from the Eventide project. If you were to go, I'll put a link to it. So I need to do this on a different computer here. I can post URLs in here. Docs.event. Right. This keyboard is difficult to reach. Project.org. You can't see what I'm doing right now because one computer I code on and the other runs the stream. So let's see here. User guide, doctrine of useful objects. This document, if you're just starting in a boot camp, is probably a little dense right now. So I just want to give you it as kind of like a background information kind of thing. See, our crispy chicken, trying to get into Ruby to see if it's any easier. Yeah, give it a shot. And if you have questions, like Ruby questions, and I'm streaming, feel free to come in and ask them, like, in all seriousness. But see, SB Ditto, you say I'd focus more on learning good design and the concepts of FP and OOP, then produce a good design regardless of the paradigm. I would second that 100%. There are concepts of programming that are the same, whether or not you're doing functional programming or OOP. And so it's kind of like learn those underlying concepts and then express them in whatever language you're doing. MERNstack, that's Mongo, Express, React, and Node, if I'm not mistaken. That's a fine stack to get started with. Okay, so yeah, this is what I want to get at. So that document that I just linked there that talks the doctrine of useful objects. Here's a takeaway that I want to get to, and then I've got to get back to my day job. They have a header in here that objects are behaviors first and data second. And so most of the OOP teaching that goes on out in the industry, they tell you those things, objects are nouns, methods are verbs, which is very much objects are data focused first. Like, here's a user class. It has all this user data and has methods you can call. And so you do weird things like you're getting data from classes, making decisions about it, and then manipulating the class based on that. And that is so backwards. And so if you take this approach that objects are behaviors first, they're stuff that you do rather than representations of data. Let me show you what that looks like. So here in the code, hopefully this makes sense. Like, you've probably seen function calls in languages. And so you might wonder, like, wouldn't write be just a function call? like so. But you notice there's a dot here, which in Ruby means the same thing as having a function or method called call on it. So when you make your objects behaviors rather than data representations, when you actually go to use them, they feel a lot like functions. So there's a call method on this write instance here, and that's what I'm calling when I do this. This class exists to perform whatever is inside that call method. And so does it have to store some data? Yes, this is writing to a database. So it needs to store some data, like its database connection, that kind of a thing. But I don't care about its database connection. I just want it to write something, to do this behavior of writing some data to a database. And so what it comes down to is like, now that I've learned more about object-oriented programming and how it's actually supposed to work, in like 95% thanks to the folks behind the Eventide project, I don't see a huge difference between OOP and functional programming anymore. And so it's just a matter of what language are we using on the project. I'll just use that. Oh yeah, sorry, Alvi. I've got a very aggressive bot here that if anyone besides me posts a link, then it removes it. If you do it again, it'll ban you from the chat for a little bit. So heads up on that. If there's some way that you can post, like maybe the domain of the URL is one message and then the extension on another. Otherwise, I don't know, you can find me on Twitter and tweet at me. I'm just at Ethan Garfull. You can see down on the little frame where I show up on the camera. But anyway, I hate to be rude. I do have to leave. I do this on my lunch hour, and so I'm 6 minutes over. But I'm going to call it here. Feel free to come back if you have any questions. Good luck with the boot camp. And Lord Crispy Chicken, yeah, give it a shot. And just remember that, like, lots of us who have gone this way before, it was tough at first. I think the first programming language is the toughest one to learn by far. Like between programming language, there's so many concepts that are in common. And so when you're learning your first one, you don't have any of those concepts yet. So good luck in making that decision. And then let's see, SB Ditto, you said it isn't too confusing to say, but the originator of OOP wishes he had called it message passing instead. Yeah, not calling functions on things, but it would be like if I sent you a message that was like, go buy me a hamburger or something. And then I don't care anything about how you go and make that hamburger happen. All I care about is that you get me the hamburger back. And that would be more of a behavior. I just sent you a message and you receive that message and do it or not do it, depending on whether or not that's something you do. But anyway, from front-end masters, I've heard good stuff that they'll teach you how to use libraries like React pretty well. I've not used their stuff myself, but people I work with speak highly of it. But anyway, I really do need to get back to work. Thanks everyone for coming today. Have a lovely day. See you next time, and happy coding.